Hi, what we're looking at here is a power switchover box which I made, and what it is this cable over here is connected to the grid from the house, goes into this box, energizes a relay, and the power comes out here to power this is a water system for the house, and this is the freezer, which is underneath here. Just move some stuff. But this one here, I've got main power. I've labelled it on there. So when this main power trips out, which is this cord here, going up to the plug. Now if I turn that off, you'll hear a click on this. You won't see anything, but you'll hear something maybe. You don't really hear it, but now the freezer is still powered, because now it was powered by the inverter. Don't see any wattage at the moment, probably because the freezer is at temperature, so the compressor's not kicking in at the moment. But that is powering the freezer. When I turn that back on, you might hear the click when I turn it on. Yep, there's like a little click. So that's energising the relay back onto the grid side. So that's what the box is. So I will add a bit more details of what's inside and how it's wired. Okay, so what we're looking at here is the type of relay that I used, just hence the one that I did actually use was 240 volts AC, whereas this one is a DC one. So the only difference is the coil, which are these two pins, was 240 volt AC, whereas the this one is 24 volt on the coil switch. But all the other switching ways are the same. Just see if I can get a better focus. Okay, so this is the type of one that I use. So the center pin is what I connected to the outlet of the power point. Okay, so let's just say this is the negative, the center that the path we choose, and that's the active or positive, whichever way you want to look at it. They're the two pins that I use, the two center pins, top and bottom, looking at it this way. So the way I connect it, so that was to the power outlet, so the so neutral and then live, and so then I bridged the okay, so then what I did for the mains input, I connected the neutral to this one of the coil and the active to that one. Then I bridged across to these first two pins, so that one being the neutral and then that one being active. So then what happens is, when this coil is energized, it then links that one to the center and then that one to the center. So it's bridging the neutral over to the neutral for the socket, and then it's bridging the active or positive over to the center as well. And then these two are completely isolated, but then when there's no power on the coils here, this one then connects to the center. Do you see how it's working? And then the power to that one is the neutral, which is powered from the inverter, and then the positive here, or the active, is also from the inverter. So what happens is, the center two are connected to the power point, and then inside here they bridge across. So these two if there's no power to the coil, and then these two when there's power to the coil. So I'll see if I can make a diagram just to make it a little bit easier to see what I'm talking about. But that's about the gist of how it works. Very simple. and very effective. And yes, I didn't mention 30 amp. So 30 amp is pretty good. And I've not had any problems so far. I've been using it for over a year. Had no problems with the coil constantly energized. That's the AC 240 volt version.